There it goes. Okay, so radical equations with rational exponents. Rational exponent just means you're going to have some kind of expression or an x, bless you, with an exponent that is a fraction. So just like yesterday, you want to get by itself or isolate whatever wherever the variable's at being taken to that fractional exponent. That's the very first step. Just like yesterday, you wanted to isolate the radical. Okay, now to solve this equation, I kind of wrote this out underneath so you can kind of see the steps, but it says by raising each side to the power. What you're going to do is you're going to create a situation where you do a power to a power. When you do that, you multiply the exponents. So if my exponent was n over m, for example, then what we're going to take both sides to is the reciprocal of that fraction. That's what we're going to do on both sides. So like in my original problem, I don't know, let me make up something. Let's say I had x to the 3/4 power, and I'll just kind of mimic what's going on in this equation here to show this to you. So let's say I had x to the 3/4 power, and I'm going to try to think of a number that this will be nice for. Let's say this was equal to 8, just as a little example. Okay, what you would do to cancel out that lovely little exponent is take both sides to the power of the reciprocal. Right? So I'm taking both sides to that power. When you do a power to a power, you multiply the exponents. If we multiply lovely reciprocals together, like this would just be 12 over 12, so that would become 1. And so then that would cancel out the exponent, and we would just have an x. Now, on the other side, and you guys can use your calculators on these if you want to, but if you want to practice doing these questions by hand, this is where we did that little bottom out thing. So this would be the third root of 8 to the 4th. Do the root first. So like the third root of 8 is 2, and then to the 4th power, that would be 16 would be my answer for that little question that I just made up. So this is just to the side here that's going through that with variables, but you're just going to take both sides to the reciprocal power. There I had a little example that actually we could solve. Okay, now here's the trick to this question. The little example I just gave you did not have this. If the numerator is odd, so in that problem I just made up, right, I had a 3/4 power to start it out. I'm going to write this. You don't need a plus and minus symbol. And then I'm going to write you a little example over here. Okay, if the numerator is even of your fraction, so like let's say I had, I don't know, let's say I had x to the 2/3 power, I don't know, I'm going to make something up, equals 9. Okay, now when I go ahead and take both sides to the reciprocal here, I'm going to use 3 over 2, right? And it might not be super obvious when you do that, but what I'm doing, if my numerator in the original problem is even, when I use that reciprocal, if I do that bottom out thing, this becomes the square root of 9 to the 3rd. If you, which I just did, introduce a square root or a 4th root into a problem, which I just did that here, you have to put that plus and minus symbol, and the question is going to end up with 2 answers. So like if I kept going with this, square root of 9 is 3, and then to the 3rd power, this would just be plus or minus 27. And both of those answers would work in the original problem. All right, so if you're doing these, you just got to be careful if you introduce a square root, 4th root, and that will happen if the numerator in the original problem is even. Now, if the numerator is odd, if I go back to this question, what I'm introducing here is a cube root, and so it doesn't have a plus minus. Any odd root, you don't put a plus and minus in front of because it doesn't have 2 answers. So if you start out with a numerator that's odd, you don't have to worry about that. If you get a numerator that's even, though, you're introducing like a square root, 4th root, probably nothing bigger than that in any of the questions that we have, but it would have 2 answers then. Okay, so as I do these questions, we're going to isolate the expression or the x that has the fraction or rational exponent. So in this question, actually, the first thing I do, just really, really quick, is I look at the numerator because I'm going to flip that over and take both sides to the reciprocal. So when we ultimately solve this problem, we're going to introduce a cube root. So this is my numerator here is odd, so I don't have to worry about putting a plus and minus symbol. This will not have two answers. It'll just have one, if any. What you do want to do first, though, real quick when you're working on this problem, is get that little set of parentheses being taken to that power alone. Do not distribute ever into parentheses that have any kind of exponent. Okay, you wouldn't write like 3x plus 3. Don't ever distribute into anything that's got an exponent in parentheses. You want to divide instead of distribute. All right, so I get x plus 1 here to the 3/5, and then that would be equal to 8. Okay, now, all you have to do, we're going to just flip the fraction over, take both sides, and this is not multiplying. I'm taking this to this power. We're not multiplying by 5/3. We're taking it to the 5/3 power. And if you want to do it by hand, completely fine. And do like, just to practice that, like cube root of 8 to the 5th. Or if you want to go ahead and do it in your calculator, you can. Just do 8 and then use the little caret button that's above the division key, and I'm just going to do 5 divided by 3 in my exponent. If you have an 83 that doesn't show you the exponent like the TI-84 does, you might need to put parentheses around that fraction, so you might just try it real quick on your calculator to make sure, but you should get 32 if you type that in, and you can feel free to use your calculator on these to save yourself some time. So I would have x plus 1 by itself now, because I'm going to cancel out that fraction exponent using its reciprocal, and it would be equal to 32. Then literally all I have to do is subtract 1. X equals 31 here. That's it. Does anybody have a question? There's no potential for an extraneous solution here. I never had anything equal to a negative number. I never had my expression, where I have my exponent, I didn't have that equal to an expression, so you don't have to, you can if you want to, but you don't have to check anything here. There's no potential for an extraneous solution in this situation. Okay, now, this next guy, first thing I want to notice is I'm going to end up taking both sides to the reciprocal power. So if the numerator's even, that's going to get flipped over. So we are going to take a 4th root here. So I need to just make myself a tiny note. If the numerator is even, that's going to end up being the index of the root when you use both sides to the reciprocal. So when I take the 4th root here, I got to remember to put the plus and minus. This question is going to have 2 answers. Just like the one we just did, though, I'm going to isolate whatever's being taken to the power. So I have 1/2 times x to the 4/3 minus 4. Get rid of any addition or subtraction first, so I'm just going to add 4 real quick. So I get 128. Now the 1/2 is not being taken to that power. How would you get rid of 1/2? What do you think? Go ahead. Multiply by 2 or divide by 1/2. Either one will work. I usually multiply by 2. All right, so once I do that, we got x to the 4/3, and what is that, 256? Let me check real quick. I think it is. Yes, okay. Now, all right, I'm going to go here. We're going to take both sides, not multiplying, I'm taking this to this power, so to the 3/4 power. Okay, and you don't have to write this, but I'm going to just have you be mindful of this. This is the 4th root of 256 to the 3rd. If you want to practice and try to do it by hand, you can. Use that little yellow card, or feel free to use your calculator. If you do this, though, because this is a 4th root, there are 2 answers here. So I'm just going to put a plus and minus in front of this. And again, if you're going to do this on your calculator, I would use the exponent. Just, do 256 to the 3/4. If you're going to do it by hand, I would do the root first and then the exponent, but this should just be 64. But because I took a 4th root, positive 64 works and negative 64 also works in the original problem. So 2 answers here. The question we just did only had 1 answer. It just depends on the problem. It only happens if the numerator of your fraction is even. If it's odd, then you don't have 2 answers. Okay, you guys try this one. Just see if you can. All right. Now, here's your potential for an extraneous solution. So we just have to check. So really, this problem, if I'm going to the 1/2 power, you're going to cancel that out. The reciprocal would just be 2. But if you guys remember, the 1/2 power is a square root. So really, this question is the square root of 5 minus x. That's really what's going on in this question. So we got to be careful when we square both sides that we don't have our expression here, can't have that equal to a negative number. If we have a square root, we can't have that equal to a negative. So I'm going to do everything else the same as we did yesterday. Your reciprocal of 1/2 would be 2. So I'm going to do the same thing to cancel out a square root or a 1/2 power. We're just going to square both sides. We just got to make sure when we get our answers, which I think this one's going to be a quadratic, we plug them back in. If our answer +1 is negative, then it's going to be extraneous, or if either of our answers are, when we add 1 to it, if it's negative, it's going to be extraneous. Okay, so this guy here, this is going to be 5 minus x. Please do not distribute the squared. You got to do a little, I know it's annoying, you got to FOIL or box that left, or that right side there. So you should get x squared, and then plus an x, plus another x, and then plus 1. So I get 5 minus x is x squared plus 2x plus 1. Now, I promise, if you do end up with a quadratic, it will be factorable. And so I would recommend set it equal to 0 so that the x squared term is positive if you want to try to factor. You can use the quadratic formula on any of these questions. I'm going to add x to both sides and subtract 5 from both sides to set that equal to 0. So we're going to have x squared plus 3x minus 4 as our quadratic. So if you want to use the quadratic formula, you can. If you can think of the factors, I think that's a tiny bit faster than the quadratic formula. So maybe try that here. Can you think of two numbers, if you multiply them, you get -4, same two numbers, you'd add them and get 3? So multiply to get -4, but add to get +3. What do you think? Yes, okay. So one of these will be a +4, one of these will be a -1. If I do 4 times -1, that's -4. 4 plus a -1 or 4 minus 1, that's going to give you a 3. Now, actual answers, whatever sets those equal to 0. So -4, +1. Okay, now we just got to check really quickly. And I wrote too big, so I'm going to zoom out on this real quick so you can see the original problem up here. I can't have a square root equal to a negative. So if I go back up here, right, if I plug in -4, it doesn't matter what the number is, -4 plus 1 would be -3. It just matters whether it's positive or negative. So, terrible, that's negative, so that's not going to work. That's going to be an extra solution. If you plug in 1 plugged in up there, 1 plus 1 would be, doesn't matter what the number is, just matters if it's positive or negative. That's positive. So the 1 works, and the -4 doesn't, because that has you putting a square root equal to a negative number. So that's got an extraneous solution there. Is anybody having a question? Okay. Make this big again so I can read it. Okay, now this one is super tricky. So I have on one side the 1/2 power, and I have on the other side a 1/4 power. Any idea, this would be kind of like a square root on one side and a 4th root on the other side. Any idea how I could cancel out both of those fractions? Like I have two different fraction exponents. Can you think of a number maybe we could take both sides to that would cancel both of them? I just don't want to mess around with a fraction exponent. So could I think of a number I could take both sides to, so maybe my exponent would be an integer instead of a fraction? What do you think? Exactly. Okay, if you get 2 like this, right? Try to think of the lowest common denominator between the two of those, which would be 4. We're going to take both sides to the 4th power. Now, that's going to cancel the fraction out on one side. It's going to leave me with an exponent on the other side, but the exponent is not going to be a fraction. Okay, so if I do power to a power and I multiply the exponents, on this left side, if you take 1/2 times 4, That's 2. So then that one would be squared. The other side is just going to be 3x plus 4. Now, super similar to the last question, do not distribute that squared. Anytime you have adding or subtracting inside those parentheses, you got to do like a little FOIL, or if you like the box better, do that. I'm just going to do a little FOIL on this question. Okay, so we're going to get, this is 4x squared plus 2x plus 2x plus 1. I'm just going to combine my like terms here. So I got 4x squared plus 4x plus 1. And I'm just going to bring down that 3x plus 4. Okay, now I'm looking at this and I'm maybe a little bit annoyed because I see a number in front of the x squared. So I know this is going to be a little trickier to factor. But I'm going to set this equal to 0. So I'm going to subtract the 3x and the 4 from both sides. So I'm going to get 4x squared minus x minus 3 equals 0. Okay, now I can do, on this, we could try the Berry method if you guys like that, or we could do the quadratic formula. Do we have a preference? Would you rather factor, or do you want me to do quadratic formula? What do you want to do? Berry method? Okay. All right, so if you guys remember, we haven't done this in a while, so I'm going to remind you how this works real quick. All right, you have to multiply, because this is tricky, bless you, a times c. All right, your ax squared plus bx plus c. So a is an actual number here other than 1. So I'm going to do 4 times negative 3, which is negative 12. And you're going to add to get the b value. We're going to pick these two numbers out. The b value is just whatever's in front of your x. So this is negative 1. Okay, now, if you remember this, the little trick to this method, you just start both of the factors with that first term, but drop the squared. So I'm going to start both of these with 4x. This will not be the answer. This is the fastest way I have ever learned to get you there, though. Can you guys think of the two numbers, if you multiply them, you get negative 12, they'd add to get you negative 1? Yes, yes, it would be positive 1. You're totally right. Totally right. Sorry about that, you guys. I didn't subtract properly on there. 4x minus 3x is positive 1. This will still work. Can you think of two numbers multiply, give you negative 12, add to give you positive 1? Yes. Okay, so it doesn't matter. One's a plus 4, one's a minus 3. Now, if you guys remember, when you do this Berry method, like if I FOIL that back out, that does not give me what I have right above there. So one or both of the factors is not the real factor. The way you determine that is you see if the two terms have anything in common, which in that first one I wrote down the 4x plus 4. Both of those are divisible by 4. So that's not the real factor. So I just disappear that out. It's just a little trick to the method. The real factor there would just be x plus 1 and then 4x minus 3. Okay, now as you're looking, I just kind of spot check this real quick. So like x times 4x would give me back 4x squared. 1 times negative 3 would give me negative 3. I just usually check the first and last, and that should be okay. And then my two answers, negative 1 and positive 3/4. Okay, now I would just do like a little teeny tiny check here. Let me zoom out. Okay, both sides of this equation, like one side's a square root and one side's a fourth root in the original problem. The 1/2 power is a square root, 1/4 power is a fourth root. So you can't do either one of those for a negative number. So I just got to check both sides. If I plug this number in, if it makes either side in the original problem a negative number, it's not good. All right, so if I plug in negative 1 to either one of those, this would be negative 2 plus 1. So negative 2 plus 1 is a negative. I can't take the square root of a negative. So it doesn't matter if it makes one of them negative, it's not going to work. Now, if I plug in 3/4, positive 3/4 on either side here, if you plug it in here or if you plug it in here, it doesn't matter. As long as it's a positive number, we're good. In that case, nothing is going to make anything negative if I plug in 3/4. So this one would be extraneous, but the 3/4 would work. Does anybody have a question? Okay, now, literally the only reason I have this bottom problem on here is because there is a bonus question on the test at the end of this unit that looks like this problem. Okay, now, I will not lie to you, this looks really garbagey and difficult, but it's actually not too bad to do. You just have to remember, when you get your answer, you can't take the square root of a negative number. So if I actually, on one side, I just have a square root of x. If we get a negative answer here, we might not have a solution. But I'm going to show you how to do this real quick. You're just going to square both sides. It's just a little bit weird, and your variable is as isolated as it can be in terms of the radicals. But on the right side there, I have a square root, but then I have -1 outside the square root. All right? On this left side, this is just going to be x minus 9. Now, this looks bad, but it's not hard to do. You can do this. So we're going to square or FOIL this square root of x minus 1. And I promise this is not bad. It's just a little bit weird. So we're going to FOIL, or if you want to draw yourself a box, please feel free to do that. I'm going to take square root of x times the square root of x. You can always multiply square roots. So when you do that, if they're both under a square root, you're just going to multiply underneath together. So x times x would mean that that first term, if I multiply it by the other first term, I would get the square root of x squared, which would actually just simplify to be x, because the square root and the squared cancel each other out. Okay, now I'm going to take the square root of x times -1. You would just write that as like negative, I'm going to put a 1 in front of it so you can see, like -1 times the square root of x. Then I'm actually going to get that same thing, another -1 times the square root of x, and then on the end, -1 times -1 is actually +1. Okay, simplify this just a little bit. These guys in the middle are like radicals, so -1, -1 would be -2 roots of x, and you have this 1 down here on the end. I'm just going to bring that x minus 9 down. Now, the nice part, what happens here, the x, plain x here and plain x here, if I try to combine like terms or get them all on one side, those both cancel. So the only variable I'm going to work with there is just this little square root around the x next to the -2. So really my problem, -9 is -2 roots of x plus 1. So I'm going to get that radical alone. So I'm going to subtract 1. So it'll be -10 -2 roots of x. Okay, divide by -2. That's going to cancel the negative there, so you're going to get 5 is equal to the square root of x. Totally fine, we can have a square root equal to a positive number. How would you finish solving this question? Square both sides, exactly. Okay, I don't know why, sometimes people, I don't know what they do when they do this, but sometimes they write some weird stuff, or they'll just write x equals 5. This would be 25 as your answer. These are super easy to check, but I would just look real quick, make sure you're not taking the square root of a negative. 25 minus 9 is 16, and then 25 under the square root, you're good. That would be the answer for that question. Is anybody having a question?